Hi guys, it's Richard again. Hope you're well. So in this video, we are continuing on trigonometry, but we are going to work with general solution. First thing first, I will take you to the principles or the basics of general solution. For sine, consider this. If sine theta is equals to k, then theta will be equals to the reference angle plus k multiplied by 360, right? So this is the basic principle, and then -1 will be less than or equals to k but greater or equal to 1. This makes theta, then theta will be 180 minus your reference angle. This is where sine is positive at the second quadrant, right? So don't forget to write k, it's an element for the element of integer. So that's the general solution. That's the general solution for sine. So that's the basic principle that you must know when working with a general solution that has a trigonometric ratio of sine. So let's consider this then. If cos theta is equals to k, then theta will be plus or minus the reference angle plus k times 360. And then -1 is less than or equal to k, but k is greater than or equal to 1, right? So k is an element of integers. You can also look where cos it's positive on our cast diagram, right? So similarly, if tan theta is equals to k, then theta will be equals to the reference angle plus k multiply by 180. As we know that the period of tan is 180 and the period of sine and cos is 360. So that's the basic behind this. No? So let's say you are required, in this video, we are going to work with a general solution that requires a factorization. So let's say they say determine the general solution. The general solution. Let's say they say determine the general solution that has 2 cos squared theta plus cos theta minus 1 equated to 0. So such a general solution requires a factorization. It's very important to know factorization in this case. So to make things easier, let theta be k. So we are going to have 2k squared plus k minus 1 equated to 0. So for us to factorize such, what are the factors of 2k squared? It's 2k and k. What are the factors of 1? It's 1 and 1. Then let's cross multiply. We're going to use what you call cross method. 2k multiplied by 1, it's 2k. And 1 multiplied by k, it's what? K. 2k minus k, it's k. So these factors are suitable here. So let's take this thing and put it here. So we are going to have 2. Remember that this k represents cos. So we're going to put 2 cos theta. And the factor there, it's what? 1. We shall put 1 here. Okay. Remember k represents cos. So we're going to put cos theta, right, as well as minus 1 equated to 0. Oh, sorry, I should have not put the signs now. Yes, I was in a rush. So if here your last term here it's negative, you will have different signs. This one will have a negative sign and this one will have a positive sign. We will then equate everything to 0 then. We are going to have 2 cos theta, which is equals to 1. And then this will be, it's the same as equals to 1, but let us put it to 0, right? Equate everything to 0. So this will be cos theta plus 1 equated to 0. Then to make cos theta the subject, we're going to divide both sides by 2, but let's transpose -1. So we are going to have 2 cos theta, which is equals to 1, then divide both sides by 2. So this will be 2. This and this, they cancel. Then we're left with cos theta, which is equals to half, or or similarly here we're having cos theta, which is equals to -1. Okay, so in this case we are required to remember they said determine the general solution of this. So to determine the general solution, we need to find the reference angle here. What will be our reference angle here? Take your calculator there, then let's say for cos, shift second function of cos there, second function of cos, that will be 1 over 2. What is that? Let's see, let's check. That will be 60. So in other words, our reference angle here, it's 60. So meaning theta will be reference angle. Remember, it's plus or minus here. Plus or minus plus k, since we're working on cos, plus k times 360. All right. Or go to the other path. Okay. In some cases, those who are doing NSC, NSCS, so NCS, or right, National Curriculum Statement, they are advised that they should not put negative values for the reference angle. So yes, but if you put, let's say you're having shift, let's shift cos here. Forget the reference angle, we use positive values, so let's use positive value here. We are going to have what? 0. So in other words, here our reference angle theta, our reference angle will be 0. So in this case, we are going to have theta is equals to 0 plus k times 360. Remember that, don't forget to write k, it's an element of integers, right? So if you have used -1, you will get 180. So your solution will be theta will be plus or minus 180 plus k times 360. So that's how you can solve a general solution, right, that requires a factorization. You can use this technique. Right, for the other solution, you can also find other solutions. These are not the only solutions that we are having here. By using a cast diagram, you can find other solutions. Hope you find this video useful, and in our upcoming video we will look at a general solution that requires reduction formula and negative angles. We love you. Don't forget to subscribe.